Guys, so this time naman, so balikan natin guys yung Bernoulli's energy equation. So consider a hydraulic system and i-assume natin na siya ay isang ideal system. So when we say ideal system, ito yung type ng hydraulic system na wala kang losses. Okay? There is no losses. So again, i-apply mo lang yung law of conservation of energy. So again, consider here a flow. So from point 1 to point 2. Okay? So the energy at point 1 will be equals lang do sa total energy do sa point 2. Again, yung E1 natin, so again, ito may kanya-kanyang velocity, may kanyang pressure, may kanyang distance or yung height niya away from a reference datum. So that will be V1 squared over 2G. So that is our velocity head plus P1 over gamma, the pressure head, and then plus Z is equals to V sub 2 squared over 2G plus P2 over gamma, and then plus Z sub 2. So another type o another classification ng ating hydraulic system is yung tinatawag na non-ideal system. So kapag sinabing non-ideal system guys, so dito naman, meron ka ng losses na tinatawag. So in actual kasi guys, hindi mo maiiwasan na magkaroon ka ng losses. So guys, yung losses, this is sometimes called as our head loss. Okay? Or on other books, so yan rin yung tinatawag na pressure drop. Ayan. So, ano ba yung mga factors na naka-apekto doon sa ating mga head losses? So, una dyan is yung ating pipe friction. So, sa loob kasi ng pipe, syempre hindi naman kasi ganun ka-smooth yan and depende rin sa type ng materials na ginagamit mo. Aside from that, meron din tayong mga bulb splitting. So, yung mga bulb splitting, ito yung mga connection na ginagamit mo para mapagdugsong yung mga pipe. And last will be because of some devices and equipment. So usually naman guys, itong mga head losses na yan is sinasabi naman yan sa problem natin. So consider again the same example. So ayan, so meron tayo ng flow kung saan coming from point 1 to point 2. So ito, hatiin natin into several points. Ayan. So this is point A, this is point B, point C, and point D. So our equation for that is yung the total energy mo kay point 1, so minus nung summation ng mga head losses coming from point 1 to A, from A to B, from B to C, from C to D, and from D to 2. Okay? So again, yung head losses mo is susubtract mo dun sa iyong total energy at point 1. Okay? So ganyan lang yung general equation yan. Is equals dun sa total energy at point 2. So guys, itong non-ideal system mo, sa susunod na slide is makaka-classify pa siya sa dalawa. So ano yung dalawang yan? So una, meron tayong tinatawag na non-ideal system considering a pump, and yung isa is considering a turbine. So mas maunawaan nyo yun. So mamaya, i-discuss natin yung difference ng dalawa. Okay, so yung total energy for 1, so same lang din naman dito. Ang nangyari lang, nadagdagan ka ng head losses. So i-copy lang natin, V1 squared over 2G plus P1 over gamma, and then plus Z1. So yung iyong total head losses, so ito yung mga head losses na makukuha mo. So for example, ito. So from 1 to point A, plus yung head losses mo from A to B, and so on. Hanggang maarating ka doon sa head losses from D to point 2. Ayan. So pagsasama-samahin mo lang yung mga head losses dyan, so that will be equals lang doon sa total energy doon sa point 2. U2 squared over 2G plus P2 over gamma, and then plus C2. Okay? So take note lang guys, dyan, ang sign convention yun. So ang pressure mo will be considered as positive if ito is a positive gauge pressure. So sasabihin naman to sa problem. Positive gauge pressure. And kailan ba po siya nagiging negative? So ang pressure mo is magiging negative kapag in-indicate sa problem na yun is under a suction or a vacuum. Ayan. So kapag suction or vacuum, so the pressure will be negative. And yung Z mo, yung Z will be positive if ito is above the datum line. So, di ba nagsasa tayo ng datum line? So, kapag nasa ibabaw siya ng datum line, siya ay positive. And that will be considered as negative if siya is nasa baba ng datum line. So, below datum line. So, para mas maunawaan, if i-consider mo itong diagram na to, ito, so let's just say na ang ginawa nating reference datum is nasa gitna nila. Ayan. So, if this is your datum line, the value of the Z for 1 will be negative Z1. And for the point 2, so since nasa taas siya, so the value of Z sub 2 will be positive. Okay, so I hope clear tayo sa point na yan. Okay, so in addition to those key pointer, so take note also of the following. So sa mga problem, ito yung usually na-encounter natin na cases. So take note of this. So note. So this is the description. So hatiin natin siya into column para mas lalo maunawaan. This will be the figure. So ito will be our for the value of the velocity head. And this one will be for the pressure head. So kailan ba siya nagkaaroon ng value? Kailan nagkaaroon ng walang value? So if sa problem is sinabi na siya ay under the category of a open tank, or sometimes ito is under the classification of reservoir. So ito is our malalaking container kung saan dyan mo ini-imbak yung tubig mo. So usually, ang figure niyan, ayun nga. So ganyan siya. And then yung ibabaw niya, since open tank siya. So open lang siya sa atmosphere. So guys, since napakalaki ng container na yan, alam naman natin na paglaki ng area, pagliit ng velocity. So the value of the velocity head there, do sa ating energy equation, will be equals to 0 or i-disregard mo na siya. At the same time, if open yung tank mo, the pressure head will also be disregarded. Okay? So another category natin is for the pipe opening. So ito yung mga dulo ng pipe. So ito is, example nito are yung mga jet natin. So for example, this is your pipe. Ayan. And then, let's say na ito yung tubig natin. Ito yung point 1. Ito sa, yan, yung open sa atmosphere. So since open din yung sa atmosphere, guys, yung pressure niya dito sa point 1 na to, the pressure head will be also neglected. And since yan ay dumadaloy sa pipe and we assume na yung pipe mo is very small, so ang nangyayari dyan, may value po yung ating velocity head. Now, next category natin is for a closed pipe. So ano naman yung nangyayari sa closed pipe? Pag sinabi naman closed pipe, yung point 1 mo is inside the pipe. Ayan. So ibig sabihin, if you're going to consider the cross-sectional area of that, kung sisilipin mo sa gilid, may internal pressure yan na nararamdaman kasi nasa loob ka nga eh. So meron siyang P. Therefore, yung value ng pressure head mo has a value at the same time since nasa loob siya ng pipe. And we assume that yung area niya is smaller compared to sa mga reservoir. So meron din siyang value ng velocity head. Okay? Next category is for a closed tank or closed pressurized tank. Closed pressurized tank. So ano ba ang magiging itsura ng figure na yan? So I don't know if naka-encounter na kayo ng ganito, pero ang magiging itsura niyan. So since closed tank yan, so parang reservoir lang din siya. Kaso since closed nga siya, and usually sa ibabaw niyan, meron siyang gauge pressure. Okay? Meron ditong bulb na sinusukat yung internal pressure sa loob. So yung pressure na yan, ang tendency niyan is to push down the water. So let's just say na ito yung ating point 1. So since closed tank na yan, meron siya ngayong pressure. But since tank siya or can be on the shape of a reservoir, malaking container again. So ang velocity head lang dito will be disregarded. Okay? So those are the following tips na kailangan niyo tandaan if ganyan yung ma-encounter niyo sa isang hydraulic system na problem. Okay, so dumaon naman tayo sa pangatlong condition. So this is a non-ideal system din, but this time with pump. So ano ba yung pump natin? So a pump kasi is a device. So this is a device or an equipment na ginagamit para ma-increase yung ating energy head of a fluid. To increase the energy head of a fluid. So ano ba yung ibig sabihin natin? So, for example, meron kang point 1 and then ang gagawin niya is to supply a water at a very high elevation. So, let's say na yan ay point 2. So, para ma-supplyan niya yung point 2 ng tubig, so kailangan ka mag-install dito ng pump. So, ang pump ka, so from the term itself, pump, bobombahin mo yung tubig papunta sa higher point. Okay? So, pag ganyan yung function niya. So, if you're going to apply the energy equation, yung law of conservation of energy, so mangyayari lang dyan is yung E1, and then again, minus yung magiging head loss niya from point 1 to point 2, or the summation of head losses, and then plus, so ito yung energy na maproproduce ng pump. So, it is denoted by HA. So, ang HA mo, where HA is equals lang sa heat added. Ano? Or ito yung energy nga na naproproduce ng pump. Sometimes itong HA mo is represented on other books as HP. Hindi siya sa horsepower. Or this is the head added by the pump. Again. So, heat added by the pump. Kaya naging HP siya. Pero ako, I prefer using HA. So, heat added by the pump. So, equals lang siya dun sa iyong energy, total energy at point 2. So, if you're going to expand that, so yung E1 mo, again, that is equals lang sa velocity head for point 1, V1 squared over 2G plus P1 over gamma, and then plus Z1, so minus the summation of the head losses, plus HA is equals do sa energy, total energy at point 2, so Bu sub 2 squared over 2G, plus P2 over gamma, plus Z2. Okay? So, ito yung ating magiging equation lang. So, positive yung HA niya dito sa kasamahan ng E1. So, next, dumako naman tayo sa pang-apat na condition. So, this time, this is a non-ideal system with turbine. So, ano naman yung function mo ng turbine? So, kung ang role ng pump mo is to increase the energy of the head of a fluid or bombahin siya, ngayon, ito namang turbine mo. So, this is a device or equipment kung saan ang goal niya is to extract. So, this is used to extract energy. Energy from fluids. So, saan ba kayo madalas na nakakarinig ng term na turbine? So, example nito is yung wind turbine natin. So, meron dyan sa Ilocos and yung papuntang Quezon. So, ayan. So, turbine, so ang nangyayari nga dito, yung wind energy, ina-extract niya yung wind energy para maging electrical energy. So, ganun lang din yung function ng turbine sa kapag tubig yung pinag-usapan. So, ang nangyayari lang dyan, ina-extract niya yung energy produced by the water para maging electrical energy siya. Okay? So, ang kanya namang energy equation is magiging ganito. So, if isusulat mo siya, so, for example, para lang din mas ma-illustrate natin. So, ito yung point 1 mo. So, ang nangyari lang dito, coming from high point, ang nangyari, papunta siya doon sa lower point. So, dito sa gitna, magkaaroon ka ng turbine. So, yung flow nga ng tubig mo, diyan ka nagkaaroon ng extraction ng energy. Okay? So, ang energy equation niya is magiging ganito lang. So, E sub 1 is equal, so minus the summation of the head losses. So, minus HE. So, ano ba yung HE natin dito? So, yung HE mo, HE is the heat extracted. O ito yung na-extract na energy from the flow of water. Heat extracted. So, sometimes on other book, yung HE yan, so ito yung denoted by the symbol HT. So, this is the energy head extracted by the turbine or the heat extracted in the turbine, kaya HT. Pero ako, ang ginagamit ko is yung HE kasi ito yung naituro sa amin before and mas sanay na ako dito. Ano? So, equals lang sa total energy at point 2. So, if you're going to expand this equation, ang magiging equation niya, so ilagay ko lang dito sa baba, is P1 squared over 2G. So, P1 over gamma plus Z1. So, minus the summation of all head losses. So, minus HE is equal to the velocity head at point 2 plus P2 over gamma, and then plus Z sub 2. Okay? So, ayan lang yung difference ng dalawang equation na yan. So, nangyari lang, palatandaan, kapag heat added, i-add mo siya sa total energy do sa point 1, and kapag heat extracted or turbine, isusubtract mo siya do sa total energy do sa point 1. Okay? So, what are the following na kailangan nating i-take note dito sa mga problems na to? So, take note. So, for pump and turbine, so usually guys, ang kino-consider kasi natin dito is yung unit ng power. So again, ang power natin, paano nga ang unit ng power natin? So di ba yan ay equals lang sa energy over time? Okay? So ano nga yung unit natin ng energy? So di ba ang energy mo is force multiplied by distance. Okay? So over the time t. And usually ang units niya is Newton meter per second. Where yung Newton meter mo, so that is in joules per second. Or ito can be written also in watts. Okay? So ang equation mo for power, so kasya pa ba dito sa baba? Kita ba to? So P is equals to Q gamma E. So paano ba na-derive yung equation na yan? Okay? So using the fluid properties na gamma. So, saan ba equals ang gamma? Di ba yun ay equals lang sa weight over volume? Or if you consider mo in SI unit, so that is Newton per cubic meter. And yung isa, so ano ba yung Q natin? So, ang Q mo is the flow rate. So, usually in the terms of volume per unit time. So, ito is in cubic meter and then seconds. So, kung mapapansin nyo dyan, so para mahabol natin yung unit ng power, so pag pinag-multiply mo yung dalawa, di ba maa-cancel lang itong cubic meter. So, natira sa'yo is Newton per second. Okay? So, saan mo kukunin yung value ng M? So, dyan papasok yung total energy. Di ba yung energy mo, if you're going to consider the equivalent height of that, yung na-discuss natin earlier, so manggagaling yan sa velocity head, sa pressure head, and yun sa Z natin or yung reference niya away from a certain reference point or datum. Okay? So, yung value ng I mo dito, if turbine yung pinag-uusapan, so ano nga pag turbine? So, pag turbine, ito yung heat extracted. Yung makukuha nating value ng HE. And kapag pump ka, so ito yung HA natin. Okay? So, ito yung equivalent value ng E o yung energy. So, again, kapag turbine, heat extracted. Kapag pump, yan yung ating heat added. So, clear tayo dun, eh? And, usually, yung unit ng powers natin is measured in terms of, ito nga, so meron tayong watts, meron din tayong kilowatts. And aside from that, in English, that is in pound feet per second. So, ano pa bang unit natin ng power? So, siguro familiar kayo sa unit na HP or horsepower. And then, meron din tayo ng tinatawag na BTU per unit. So, ano ba yung ibig sabihin ng BTU? So, this is the British Thermal Unit. So, pakitandaan na lang. So, yan yung ibig sabihin na BTU. Okay? So, next. So, ano ba yung ating tandaan dito sa power na to? So, to share lang, so ito yung mga usual conversion ng ating mga units in power. So, take note of this. So, ang gawin na lang natin, ang reference unit natin is yung horsepower. So, 1 horsepower daw is equals lang sa mga sumusunod. So, 1 horsepower is equivalent lang sa 746 watts. Okay? So, if you're going to consider that in kilowatts, so divide mo lang ng 1,000 or that will be 0.746 kilowatts. So, ang 1 horsepower mo in English unit, so that is equals lang sa 550 pound-feet per second. And if you're going to consider a minute, so, i-divide mo lang siya ng, i-multiply mo lang siya ng 60 or that is equals lang sa 33,000 pound-feet per unit. And in BTU o the British Thermal Unit, so equals lang siya sa 42.41 BTU o British Thermal Unit. Okay? So another thing na kailangan yung tandaan dito or another key pointer natin guys is kapag pump, guys, another thing to remember kasi dito sa mga problems, madalas maririnig yung word na efficiency sa mga power. So, ano ba yung equation natin for efficiency? So, this is a general equation kung saan yung efficiency mo that is equals lang sa P out or yung output mo, the power output over the power input and then multiply that by 100%. Okay? So, tandaan guys, kapag pump, so for example, ito nga yung pump natin. Pump. So, ayan. So, ang pump, di ba, binobomba mo yung tubig pataas. So, para mabomba mo yon, ito, meron ka ditong P-in, yung input, power input, and then ito, meron ka ditong power output. Ano ba yung magiging input natin? So, para maarating yung tubig sa mas mataas na point, so, meron ka ditong papasok na mechanical energy. So, yung pump mo, meron kang mechanical energy na nangyayari dyan. So, yung machine mo, kaya nga, papaanda rin yung pump para mapataas na yung tubig. So, yung magiging output mo, ito yung magiging hydraulic energy. So, if you're going to consider the equation for the power, di ba? Q, gamma, E, kung saan yung E natin dito is yung ating heat added. Tama ba? Oh, tama. So, heat added. So, anong nangyari dyan, yung power mo dito, ito is yung magiging output. Ano? Kasi nga, yung hydraulic energy mo, nangyari lang siya because of this input, kung saan yung mechanical energy, yun yung kung paano ba nangyari yung pump na yan. So, meron ka mga machine, pinaandar niya sa loob para magkaroon ka ng output na hydraulic energy. Okay? So, ang output mo dito, kapag pump, ayan, yung power mo is yung output. So, ito yung equation niya. Ayan. So, kabaligtaran lang guys na mangyayari dun sa turbine. So, pag turbine naman, kabaligtaran lang siya. So, again, ito, siyempre, coming from higher point pababa, nag-extra ka nga ng power, ng energy dyan. So, meron kang turbine. Ayan. So, ang pumapasok sa'yo, di ba? Ang pumapasok dyan is yung hydraulic energy. And then, yung hydraulic energy yan, hydraulic energy na yan, so, nangyayari, yung turbine mo, ikino-convert niya into electrical energy. So, kabaligtaran lang na nangyari, di ba? So, ang mangyayari lang dito, yung equation mo for P, Q, gamma, E, or again, yung E mo, so that is Q, gamma, ng heat extracted, ito is yung magiging output kasi ito yung di ba, pumasok yung tubig and then nung lumabas siya, naging electrical energy. So, ang mangyayari lang dito, yung P mo dito is the PE. So, tandaan niyo lang, magkabaligtad lang yung dalawa. Ayan. So, yan lang yung kailangan nyo tandaan sa topic na yan. Okay, so, dito tayo nagtatapos. So, let's try this on an example or let's proceed with the next topic.